Okay, Bismillahirrahmanirrahim. I'll be talking about the typical cases of similarity today. Okay, you'll see these two kinds of shapes in my lecture. So let me take my whiteboard and then let me tell you. Now, there are three typical cases of similarity, bacho. Okay, first of all, uh, let's suppose you have a triangle. Okay, there is a triangle like this. Now, suppose this is a triangle ABC. Now, within this triangle, you draw a line which is parallel to any of the sides of this triangle. Suppose I'm drawing a line over here like this. And let me say this is um, X and Y. Now we know that this XY is parallel to this BC because that is the first thing that we uh, believing that like we had to draw a line which is parallel to one of the sides of the uh, of this triangle ABC. So this is given that XY is parallel to this BC. By doing so, we get a pair of similar triangles. And how do we get that pair of similar triangles? Look at this. First of all, the angle X is equal to angle B. Okay, that is a first typical case. I should write here typical cases of similarity. Okay, typical case of similarity. So now, first of all, you see that from the smaller triangle, the angle X is equal to the angle B. Now, what is the reason for that? The reason is that these are corresponding angles on parallel lines. Okay. Then you have this angle Y that is equal to the angle C. Angle Y is equal to the angle C. And the reason is same. These are again the corresponding angles on parallel lines. Once you've shown two pairs of the triangles equal to each other, two corresponding pairs of the angles of the two triangles equal to each other, then it is understood the triangle would be equal. Okay, so the angle A from the smaller triangle is equal to the angle A in the bigger triangle, and though it was not required, but I'm still mentioning this. So this is because this is a common angle here. It's the same angle. You just need to show two angles, two pairs of angles equal to each other. Therefore, this triangle AXY is similar to the triangle ABC. Okay, this triangle AXY is similar to the triangle ABC. And once you know that these two triangles are similar, then you can say that AX from the smaller triangle and AB from the bigger triangle, the ratio between these sides are going to be same as AY over AC, and that is going to be same as XY over, yeah, someone is entering here. So that is XY over BC. So that is the very first typical case of similarity. Let me tell you again that we had a triangle ABC, then we have drawn a line ourselves, a line which is parallel to one of the sides of the triangle, and hence you get two similar triangles because you have this angle equal to this angle because of being corresponding angles, and this angle over here is equal to this angle, again the corresponding angles. Let me tell you the second typical case of similarity. The second case of similarity. Now, in this case, the situation is that you will have something like this, and then let's say that, oh, sorry. Um, um, Now you have another like this. Now, this is uh, um, this is done in such a way that Now, yes. Acha. Now, suppose you had, now this side here is parallel to this side here. It's like this. Okay. Let me cover this up. Okay. So now, suppose if this is the triangle ABC and this is DE over here. Now we know that this AB is parallel to this DE. This AB is parallel to this DE. Okay, so what happens? Again, you will have two similar triangles. And how? First of all, this angle A is going to be equal to this angle E over here. The angle A is equal to angle E. The reason is that these are the alternate angles on parallel lines. Then you have this angle B equal to this angle D over here. The angle B is equal to the angle D. And this is also the same reason these are the alternate angles. Now, obviously, when you have two pairs of angles equal to each other, the third would be automatically equal. But you can still see that there is a very easy reason here, easy to figure out that this angle C is equal to this angle C. What is the reason for that? Yeah, these are vertically opposite angles. That is why. Remember, you just have to show two pairs of angles equal to each other in case of a triangle. Okay, so that is the simplest way of proving two triangles to be similar to each other. Now, looking at the order of these angles here, we can say that the triangle ABC is similar to the triangle EDC. Okay, ji? So, and once you have written down according to the correspondings the names of these similar triangles, then you can say that this AB over this ED would be same as AC over EC, and that would be same as BC over DC, because these two triangles, they are similar to each other. So if you go back to the first case here, you had, like, these are basically connected triangles. So within a triangle there is another triangle such that they have a parallel pair of sides. And in the second case, you have two triangles, they have a common vertex, but this again have a pair of parallel sides here. Okay, so because of the parallel sides, we have the alternate angles here, and in this case we had the corresponding angles here. Okay, now we move to the third typical case, Pacho. Now, in the third typical case, again, the overlapping triangle to the connected triangles. So what happens is you have a triangle here. Okay, now this is the triangle. And then there is another triangle inside this. Okay, let me keep it like this. Okay, now this is, suppose you have, this is A, B, C, and here it is D. And you're given that this angle A is equal to this angle B over here. So you have to tell that which two triangles are similar here. You only know that the angle A from this, like, the angle BAD or BAC is equal to the angle DBC. That is what you know. Now we have to take out a pair of similar triangles from here. Acha. Now, we have to be clever enough to identify one more pair of the same angles or the equal angles, so that we can prove that these two triangles are similar to each other. Okay. Now, don't try to assume that this is a right angle over here at the point D. So, guys, I'll be taking this angle C of the smaller triangle. Okay. Angle C from the smaller triangle is equal to the angle C of the bigger triangle. Like suppose if I'm taking the triangle CBD, the smaller triangle CBD. I'm not mentioning the names of those two triangles here because I have to show the angles correspondence and then I'll be writing their names. Now, in the smaller triangle, you can see that the angle B is going to be equal to the angle A. Now, I should have written this reasons here. Now, this is the same angle, the common angle here, okay? Common angle or the same angle. And angle B is equal to the angle A. And this is given to us. This is given already. We don't need to be worried about that what has to be the reason for this. So this was given that angle B is equal to angle A. Now look at this. Uh, Within this smaller triangle, we only left with this angle D over here. Let me put the 3 marks here. So I can say that this D is going to be equal to, look at the bigger triangle. This, we have used this angle C, we have used the angle A. So this angle B is left here. So the bigger triangles B is equal to the smaller triangles D. So guys, you should be clear about these angle things here. Don't be confused that I'm using B in both of these triangles. When I mention B in the smaller triangle, that means this angle is B over here, okay? And for the bigger triangle, this whole ABC is a bigger angle, okay? So therefore, I don't need to mention, I'm just writing these angles because I have to name these triangles. So if I name the smaller triangle as the triangle CB, you can give the reason, this is understood, okay? There's no need to be worried again about this reason here. So the CBD, triangle CBD, don't look at this diagram now, just use this. Triangle CBD is similar to the triangle CAB. Triangle CAB. You will be seeing many such questions in your past papers. Okay, now again looking at their names, you can say that the CB over CA is equal to CD over CB, and that is equal to BD over AB. That is the ratio for their corresponding sides, which are going to be equal to each other for being two similar triangles. So guys, these were 3 typical cases of similarity. Okay. So we have 2 questions here which are directly related to those typical cases of similarity. Look at this, is the first case of similarity given us ABC is similar to ADE. So we can clearly see that this has to be parallel to this. Only then, if this is 56, then this x is going to be 56. Okay, and this angle C would be equal to this angle E over here. Okay, and then you can like you have to find the x and y. So guys, AB over in the 7th question, your AB over AD would be equal to AC over AE. So your AB is 4 and your AD is 4 plus y. This is really confusing. This AB is 4, AD is 4 plus y. This y is not I mean, the sole part of any of these two triangles. This is a part of a side of this bigger triangle. Like, this AD is consists of two things, two segments. One is 4, other is y. So therefore, AD is 4 plus y. That is equal to 6 over 15. 6 over 15. This AC is 6 and this AE is 15. So this is how you will be finding this y from here. I believe you can simplify this. Look at this 8th question here. Now, we're given that PQR, this PQR is similar to BAR. So P from here is corresponding to B from here. So this means that this angle is going to be 60 degrees. And you can see that he's not telling us, but actually this PQ is parallel to this AB over here. And then if this is 60, this is 60, this is going to be 52 over here. And this is 1 and 12, and this is going to be 68. Yes. So this X is going to be 68. degrees here. Okay. And similarly, now once you have seen that, now we have to find this y over here. So y is basically br. This is your br. It will be corresponding to pr over here. So we can say that br over pr, and we have ab from here. This ab will correspond to this pq. That is going to be ab over qp. Okay, so br is y, pr is 14, and then ba is 9, and this pq or qp, that is 12. So simplifying this, you can get to the value of y. Inshallah, I'll be discussing the questions from past papers tomorrow, and you will see the problems on similarity and congruence together. And those will really be harder, inshallah. And I'll tell you people how to make them easier while uh, finding their solutions. Okay.